Hey everyone, Sakani here. Today in this video, we're going to be taking a look at the tabular method. So before we get into the problems, I want to introduce a few tips or when you actually use the tabular method. So let's get right into it. So of course, we are learning about the tabular method in this video. And the tabular method is an alternate method for integration by parts. If you don't know integration by parts, you can click on one of the corners on your screen right now, and that'll take you to my full tutorial on integration by parts with a few examples. But for those of you who know integration by parts and solved a few problems relating to integration by parts, we know that there are a few integrals where you're going to use integration by parts, but then you're going to get even a more complex integral. So as a result, we can't just keep applying integration by parts. So that's where the tabular method comes in, and that is a much faster alternative to the integration by parts formula. But there is one thing to note whenever you apply tabular method. So tabular method can only be applied when there is an algebraic piece or lower. Our integral should have one algebraic piece and one piece that is lower. In other words, it should have one algebraic piece and one piece that is lower. So, for example, if we had x cubed and then natural log of x plus 34, for example, dx, we cannot apply the tabular method over here. In order to apply the tabular method, you should have an algebraic piece and something lower. But obviously, this is the natural log, which falls in this category, which is higher than the algebraic piece. If we had integration x squared plus 1 and then sine of 4x, let's say, we can definitely apply the tabular method over here because this is the algebraic piece and this is the trig piece, which is right over here. And trig is lower than algebra on this scale. So this scale, I know it's a little bit controversial because some books say a different scale. I know one of my books says I late, but in the other curriculum that I've seen, it says late or something like that. So honestly, it's totally up to you. There are a few discrepancies between books, but for right now, we're just going to use the most commonly used mnemonic, which is LIATE, however you want to pronounce that. Okay, so now let's get into the questions. Now let's begin to actually solve this problem. So we have our first problem here, integration x squared sine x dx. So first we have to see if we can actually even apply the tabular method. So let's figure that out. We see we have an algebraic piece over here, so that satisfies that condition. And then we have a trig piece over here, which is lower than the algebra on this scale. So we're good with that. We can definitely apply tabular method. So in order to apply tabular method, what's the first step? So the first step is to draw a table. And the table is going to have u and dv. And if you're not sure where we got this u and dv, make sure to check out my other video on integration by parts. So we have u and dv, and u is going to be the algebraic piece because u is going to be one that we are differentiating. And dv is going to be the one we're integrating. Now, the reason we choose an algebraic piece for differentiating is because if you keep differentiating an algebraic piece, it's going to become simpler. Rather than integrating an algebraic piece, that's just going to make the overall integral even more complicated. So let's see what I mean by that. Let's write our x squared, which is our algebraic piece, right over there. And let's write our dv, and we're just going to write sine x. I know dv is technically supposed to be sine x dx, but for this, we're just going to write sine x. Sine x is going to be the one we're integrating. X squared is going to be the one we're differentiating. So let's start differentiating x squared. Derivative of x squared is 2x. Take the derivative again, 2. Take the derivative again, 0. And we're going to stop there. Once we reach 0, your left column is done. Now let's move on to the right column. So we have to integrate sine x. Integration of sine x is negative cos x. Integration of negative cos x is negative sine x. And finally, integration of negative sine x is cos x. And we stop right there. We don't keep on going because our left column has already stopped, so we're also going to stop the right column. We have one more step to do. We are going to write a plus minus plus minus. And this is extremely important because it determines these signs. So it will always go from plus minus plus minus. It won't go from negative plus negative plus. Just always remember to put these on the side. Now we are going to go diagonally. So a lot of steps, but we're going to go diagonally. We are going to go diagonally like this, like that, and like that. And 0 can't go diagonally to anything, so we just leave that there. Now, this is actually all we need to find our final answer. So let's go diagonally and multiply them. So we are going to be multiplying each one of them. So our answer is going to be x squared times negative cos x squared times negative cos x, which is negative x squared cos x, 2x times negative sine x, but remember we have this negative over here, so we have to include that as well. So negative times this negative, that's a positive, so positive 2x sine x. Next we have 2 times cos x plus 2 cos x, and that has a positive, so we can leave that as it is. And then of course plus c. And that is our final answer. So the reason we did tabular method is because if we did apply integration by parts, we would have to do it multiple times. But by applying a tabular method, we were able to shorten down the process by a large margin. All right, on to our next problem, which is question 2, integration x cubed e to the power of 2x dx. And I will say this is a bit more involved of a problem. So if you want to give this problem a go, pause the video, but I'm going to go over the solution right now. So once again, let's see if we can actually apply tabular method. We have an algebraic piece, and then we have an exponential piece, and then I see exponential is below algebraic, so that is perfectly fine. Let us draw our table. We have u, and then we have dv, and then drawing our table. Our u is going to be our algebraic piece, always, because it's easier to differentiate algebraic pieces, and then our dv is going to be e to the power of 2x. Now let's differentiate the left side. So we get 3x squared, 6x, 6 and 0, and then we stop there. So now we integrate e to the power of 2x, and you might need to use a bit of u substitution here if you are not completely comfortable with integrating e to the power of 2x, but I am simply going to integrate these in my head and write them down. So here we have integrated all the way up to that 0 on the left column. Now we have to add our plus, minus, plus, minus, plus. And then we go diagonal. So this corresponds to this. And then, of course, we multiply each one of them. So our final answer is going to be x cubed times this part right over here, which is positive. So 1/2 x cubed e to the power of 2x plus c. All right, so moving on to our last problem, integration 4x over e to the power of 2x dx. So first we have to see if we can actually apply the tabular method. I see that 4x is the algebraic piece and the bottom part is a exponential piece. From here, I know that exponential is below the algebraic, so we can definitely apply tabular method. Now to simplify this integral, I'm going to take the 4 out. So I get 4 integration x e to the power of 2x dx. And I'm also going to rewrite the denominator as e to the power negative 2x dx. And this just makes the integration part a bit simpler. You'll see what I mean right now. So let's draw the table. So u and dv. U is the one we are differentiating. dv is the one that we are integrating. So u is going to be our algebraic piece, so x, and then dv is going to be the other piece, so e to the power negative 2x. From here, let's differentiate the left side. So we're left with 1 and then 0. Then let's integrate the right side. And in order to do that, you might need to apply u substitution. So just quickly solve it on another piece of paper. And I'm just going to write the answers right now based on my calculations in my head. So I'm left with negative 1/2 e to the power negative 2x, and then 1/4 e to the power of negative 2x as well. And of course, we need our plus, minus, plus, always starting with that positive sign. And then let's multiply diagonally. So multiply diagonally, multiplying it. And one thing to note, this part is the answer to this part. We still have to multiply our final answer by 4 because we took that 4 out. So solving that part, I'm going to write 4x times this part right over here, which is negative x over 2 e to the power negative 2x. And then 1 times this part over here. Be careful for that minus sign. So that is negative 1/4 e to the power negative 2x. And then plus c. Multiplying by 4, we get negative 2x e to the power negative 2x. Minus e to the power negative 2x, and then plus c. And now this is our final answer.